Here we go. So the radius of this circle is 12, and then the measure of arc CD is 60. So if I go ahead and try to figure out the fraction of my circle, 60 out of 360 is 1/6. And then the radius of my circle is 12, so that means the diameter is 24, which means the circumference is 24 pi, because circumference equals diameter times pi. So then 1/6 of 24 pi would be 4 pi. Then I want to find the length of AB. Length means how long is it. The degree measure of AB is 110. So the length, I would have to use the circumference, which if the radius of the circle is 36, that means the circumference of the circle is the diameter, which is another 36, which would be 72, and then times pi. And then for my fraction of my circle, I want 110 out of 60, which is 11 out of 36. So 11 out of 36 times 72 pi gives me, remember you can always do your canceling here. And so you would say 22 pi. The diameter of this particular circle is 40, and I want to find the length of arc AC. So remember, this is double. So, whoops, 100. So double 50 is 100 because the inscribed angle and the arc are always double or half. So it's 10 out of 36, which reduces again to be 5 out of 18. And so my circumference of my circle, since the diameter is 40, the circumference would just be 40 pi. So I have 5 over 18 multiplied by 40 pi. I can do a little bit of canceling here. They both divide by 2, so that's 9 and 20. 5 times 20 is 100, so 100 pi over 9. So this time I want to find the diameter of the circle. So I got to think backwards. I know the length of this arc is 14 pi. And I know this inscribed angle is 80, which means the degree measure of this arc would have to be 160. So let's continue the process and kind of do it like we normally would. I've got 160 out of 30, or 360, which is 16 out of 36, which when I reduce it again, they both divide by 4, so 4 over 9. And so I have my arc length, which is 14 pi. Has to equal 4 over 9 multiplied by the circumference of my circle, which is diameter times the pi. And so now you can do whatever you want to try to get the diameter by itself. So if you divide both sides by pi, the pi's are going to cancel. So you're just left with 14 equals 4 over 9 pi. And then you can multiply to get rid of the fraction. So you've got 9 times 14, which is 126, and then equals 4 pi. And then 126 divided by 4 is 31 and a half. Oh, that's not a pi. That should be the diameter. So you could say 31 and a half, or you could say, you could switch that into a fraction. So you could also say 63 over 2. This one's kind of tricky. Let's see if I can get it all in the same picture here. So this is 66, and then all the rest of these sides of the shape are the same, which means the chords are all going to be the same. So I first will take 66 away from 360 to get 294, which means all the other arcs, which are created by the chords, have to add up to be 294. And there are 1, 2, 3, 4, 5, 6 of those. So 294 divided by 6, which is 49. So each one of these arcs has a degree measure of 49, which means W equals 49. And then we have, so all the central angles in here are also going to be 49. Which means now we can think about this shape. There's a couple different things we could do. We could look at the fact that we have an isosceles triangle right here. And if I draw it over here, that's 49. And that's y. That would also be y. So I could take 49 away from 180, which is 131, and then divide that by 2. So y would have to be 65.5. And then I could figure out x kind of a similar way, because I know that piece has to be 65.5 as well. So I can figure out the other piece by thinking about this isosceles triangle, which is different than all the others. So I could do 180 minus 66, which is 114, then take that and cut it in half, so that's 57. And so x would have to be 57 plus 65.5, which is 122.5. Then this one, 90, we can know this guy's 95, so I can figure out that 85. And then if I'm thinking about central angles, this arc would also have to be 85. So then I could do 180 minus 85 to figure out arc A, which is also 95. Whoops. Or I could have realized that that was a central angle. And then C, there's a couple different ways you can figure out C. This is an isosceles triangle again, so you could totally figure out C that way. Or if you realize that C is the inscribed angle of 95, you could just take 95 and divide it by 2. Either way, you get the same answer of 47.5. All right, next patch. This one we're really thinking about inscribed angles. So if I wanted to find A, extend those sides out, A has to be half of 100. So A is 50. And then C is also pretty easy to figure out. C has to be half of 140. And half of 140 is 70. And then to figure out B, B would have to be half of this arc right here that I don't know, but I could take 140 and 100 away from 360, and that would be 120. And half of 120 is 60. Again, it always helps to draw on your picture and extend your sides out. All right, so then R. R is going with this 29, so R has to be double 29, which is 58. And then if this is 58, I can think about this inscribed angle here. This inscribed angle has to be the same as that one because they both inscribe 58. And then I could subtract from 180 to find that guy. So I'll take 180 minus 87 and take away 29 as well. So I get 64 for that bad boy. And then this is inscribed here. So I can double 64 to get 128 for P. I guess I should be writing this down. R is 58. P is 128. So now I just have to find the other ones. Now note, it was easy to miss, but these two chords are marked equal. So that means that this arc has to be the same as this arc because those two chords are equal. So I can take away 128 and 58 from 360 and get 174. Cut 174 in half because both of these would then have to be the same, which would be 87. So S and P equal 87 degrees. Cool. Continuing on. This is a tangent line. It didn't say that, but you kind of have to assume it, otherwise you can't do anything with the picture. My fault for not putting in the directions. So that's a right angle automatically. So angle A is a 90-degree angle. Oh. And then the measure of arc AB is right there. So to find AB, I really have to work backwards inside this triangle and take 90 and 54 away from 180. So we get 36 for this guy, which is the measure of angle C. Now that we know C, we can find AB because that would be double because it's inscribed on that arc. So double 36 would be 72. And then to find CB, that guy, since this is a diameter, which means we have a semicircle, we can do 180 minus 72 and get 108.